Thank you so much, Vikas, for that introduction. And I'm really excited to speak with this group. Great attendance. And I hope the listeners and the participants here are as much excited about the topic that we are going to speak on today. I'm also joined here with my colleague, Chintaka, who is also going to support the Q&A in the chat. So as and when we go through the presentation, if any question pops through your mind, please feel free to put it in the chat and Chintaka will be helping answer those. With that, let me start sharing my screen. I hope it's visible to all. If I can see a few thumbs up, maybe.
Yeah, we can see it now.
Great. Thank you so much for confirming, Vikas. So, like Vikas introduced, I am Vibha Bhagchandani. I work as the AI go-to-market lead for our PRISMA AIRS solution in India. And this is a solution which is actually focused on the AI build lifecycle. And we'll speak more about it as we go. So I just wanted to start with first establishing that AI is no more a tool. Like even Vikas was mentioning, probably it really started picking up bit during COVID, post-COVID times with the mainstream application of ChatGPT coming in play. We started seeing AI applications evolving and this is probably 4 years back, but if we speak of today, we are already living in the age of enterprise agents where we have moved from AI applications that you could just interact with a response and a query structure to now enterprise agents which can actually perform, reason, and plan on your behalf as well. Now, this is not just limited to enterprise agents that you are building in your cloud and data centers, but now the world has moved on to agentic endpoints where your developer base is, even writing code using, say, Claude Code and other tools, and agentic browser where all your employees are using some or the other, form of AI tooling on the browser and using agents to perform, actions like reconciling data, creating reports, and the like. So AI is no more a surprise. It is transforming businesses as we speak. You see here some data points from IDC and Gartner that it's expected that around 1.5, 1.3 billion agents will be in production by 2028. A majority of those, also actually act in the customer service industry, which I personally, from my experience, have seen has adapted AI the most. And it's predicted that by 2028, around 80% of customer support issues will be resolved by AI agents itself. I think you might be even seeing this in your interactions when you speak, when we're interacting on a chat like Swiggy, Indigo, Make My Trip, all of this is already in play. Having said that, it is technology leaders and security leaders like yours that are bringing agentic AI into reality. While you're defining AI agents and application strategies, securely deploying your agents without risk, implementing secure AI principles by design, and doing all of this responsibly. So it's no more a surprise when you see that 78% figure on the screen that says that 78% of global enterprises are actually integrating AI into their operations. But the more alarming figure is that only 6% of organizations are actually implementing any advanced security framework. And it is security leaders like yours that have to deal with this question on a daily basis because you are chartered with the responsibility of seeing that not just your user base, but also your developer base is developing those agents and applications safely, whether they are prone to prompt injection attacks, whether there is any sensitive data leakage that might happen, whether the configurations have been done correctly, whether there are any model vulnerabilities. Like so, these are the questions that you kind of live in and day out. I'll pause there and move on to speaking about AI, segregation before we move to the next phase, which is about the build life cycle. Now, we all know that AI revolutionizing businesses. However, it's broadly you can look at it in two ways. One is employees that are using AI applications, whether it is ChatGPT Enterprise, Microsoft Copilot, Gemini Enterprise, all these toolings that are you are giving to your employees to improve their productivity and efficiency at the same time. And then on the other end of the spectrum is enterprises that are building these AI applications. So today's focus is going to be on the second part, which is enterprises that are building AI applications. So as I, was thinking around preparing for this webinar, I thought let me put a thought map across how a security professional like yours would think about AI security, or rather, should have a mental framework in terms of how do I think about security when I'm building my AI applications. Say one of your application development teams is given a charter to build an AI application, an agent. The first thing that you need to ensure is that the right team, the right users have access to the right tools with the right permissions to perform this activity of building an AI chatbot or a agent. Now, as you do that, and your application development teams or AI development teams come in play, the first thing that they think about is what is the model that I want to use, because that's kind of the brain of your agent. When they think of it, a lot of times I've seen enterprises go with foundational models, like an Azure OpenAI model or something from Anthropic or Gemini directly, or if your use case and business demands it, then you fine tune your model. You pick up model from the open source, you fine tune it further, you custom train it, and that's when you have to launch or use that custom model. So you have to also, now the responsibility lies on you, because now your developer base has developed those models. You need to make sure that it is safe. Then you proceed, you go ahead with the application development process, at which stage you have to ensure that the environment is secure, there are no misconfigurations, the permissions are correct, the network is secure, etc. Now, when the application is ready or the agent is ready, now you want to make sure that it is safe to deploy. Like any other, software development life cycle, or a software, you also have to make sure that your AI agent is also secure. However, there's a catch in it, because testing AI applications is not as straightforward as any other traditional application that we have seen. Now, when that is done, you are you're sure that your application and your agent is safe. You implement the different security controls and you bring it to production. Now, at the production level itself, you need to make sure that all the interactions that are happening with your agent are secure, like the inputs or the queries or the tasks that are assigned to the agent, as well as the output or the action that is taking on your behalf. All of that has to be secure. So this is more of a mind map that you need to keep in mind, and also think of this as more of an iterative process, because as and when your use case changes, your models evolve, your code base changes, or your behavior of your application and agent itself shifts, you have to make sure that you do this iteratively and you secure in a more continuous manner. Now, it's not that there are not products in the market to solve for that. There are different products that apply at different stages of the thought process that I just showed you. But the idea is, when you rely on point products, you create a gap. Not just a gap for creating more threat surfaces for security threats to seep in, but also an engineering overhead. So when you think about AI security end to end, you need to always think about it from a platformization approach. And the way we at Palo Alto are looking at securing the AI development lifecycle, the answer that we have to that is our PRISMA AIRS 3.0 solution, which is now in its 3.0 version, where we have divided or look at AI development security in a three-pronged pillar approach. First is discovery. Second is assessing the risk associated with all your AI asset. And thirdly, and most importantly, protecting once things are in runtime. And to implement these three pillars, we have different solutions in play that I will walk you through as we move forward. And hopefully, if we have time, I'll also cover a short demo towards the end to bring all of this in action. So now let's talk about discovery. When we speak of discovery, everyone knows that if you can't see anything, you can't protect it. So the very first aspect of security becomes discovery, and unfortunately, traditional security systems are blind to the way AI is operating in the enterprise. You may ask why. I think you would have all seen it in all the organizations that you work. There are different business units procuring different business tools, AI tooling or AI applications or SaaS agents from different providers, you as a security team probably do not have even an information or access to that knowledge that different business units are using those tools, which is why you lack visibility into the traffic, which models are being used by which users and how much, which actually creates the concern that you cannot secure, and because of the inability to identify where the risks lie, because you do not, there's a lack of visibility itself. Now, that's where the discovery of an AI enterprise ecosystem becomes very critical. The very first aspect of this is creating an inventory of all your AI apps, agents, models, and datasets. It gives you visibility into which application is using which model and being used by which user at what time. So this is what a discovery module kind of gives you an access to. And when you start on your AI build lifecycle security journey, the first thing you need to think about is discovery, and how do you make sure that you have visibility into all your traffic, because only when you have visibilities you might be able to then take actionable insights depending on the risks that you are exposed against. This is where you get information of all your AI assets in your enterprise. Now, moving on to assessment. So, once you have discovered what all your AI artifacts, AI assets reside within your enterprise, including your users and your AI applications, it is important to assess the risks associated with it. Now, let's talk about traditional security tools. Unfortunately, the security tools that we have used so far are not sufficient to test for AI applications, and for the very plain simple reason that AI applications and agents are not deterministic. What it means is, for example, you have, I'm sure all of you have interacted with some form of AI. If you give the same exact question 3 or 5 different times, you might get a similar response, but not the exact same language, which means there is a degree of randomness to how AI applications and agents are built. And that is inherently because the supply chain of AI itself is different. We now have models that we have to secure, and there could be vulnerabilities in the model itself, and thus point in time or rule based scans that we used to perform in the past are not sufficient anymore. So, having said that, it is important that AI applications and agents are also tested before deployment, but the methodology and the tooling that you need to do this might be different. Here, if you talk of the artifacts that are typically involved to build your agents, it's of course your application code base and the data layer. But now you also have models. You also have tools and plugins. You have memories that agents have access to, and they need to be secured against that. And in terms of securing all of that, we have different tools and methodologies provided, and I'll walk you through some of these as we move forward. So let's talk about agent artifact scanning. Like I was speaking a bit earlier, when it comes to an agent, it is not just a simple AI application. Now, the way I explain an agent is something which has agency, which means it can act. To act, it needs access to a tool to perform that action. It needs access to memory to be able to contextualize its action, and also of course it has a model, which typically for an agent is a high performance reasoning model. So it means you just don't have to scan your models anymore, but you also have to scan your code base, that builds all of this and brings all of this together. And if you ask me why, we all know that a lot of code these days is being built by agentic applications itself, which means there can be vulnerabilities that can be introduced, which our developer base might itself not be aware of, which is where it is important to not just scan your models, but also all the artifacts related to your agent, and find those vulnerabilities in the model files, in skills, in your tooling. And once the agent artifact scanning ideally gets completed, it also provides you a recommendation to fix those, to fix those issues. And I'll walk you through a bit of this as we move forward to the demo. Now let's talk about the second pillar of assessing, which is agentic red teaming. Now, we were talking about, how AI applications are actually built. They are not deterministic, and hence a fixed set of, test cases do not suffice anymore, because for the same exact question that you send, you might get multiple different responses. So the permutation and combinations that exist are multiple, and it's very hard for you to test, against all those vulnerabilities or all those responses that can come out of an AI agent, or all the actions that it can perform. Now, to be able to perform, a red teaming, there are different. So the idea is that human-based or human-designed red teaming might not always be sufficient, especially with agentic applications. Now, let's talk about, how do you perform red teaming. Typically, when you perform red teaming, you can do it, you first have to set a target that you are red teaming for, right? This target can be your AI application, this can be your AI agent, or it can even be your model. And then we, define a scan that you need to perform on this target. Now, the scans can typically be static scans, or they can be agentic scans. When I talk of static scans are something, which in Palo Alto, our threat intelligence teams have built a curated library of attacks from their knowledge and research over the years, that you can use, as you start this journey, as a low hanging fruit exercise. You have a simulated attack library that you can use to simulate the behavior of your application in real time before you take it live. The other option that is typically available to you is doing an agentic red teaming. Now, what do you mean by agentic red teaming? This is where you profile your agent or your application. What that means is, the profiling agent comes in play. It identifies what is the system behavior, what is the goal, what are the actions that your application has been designed to perform, and accordingly, it creates or customizes its own attack mechanism to be able to break the system. That's how you perform agentic red teaming. And we have around 50 different attack techniques that our teams have curated over a period of time. Now let's move on to the last, but I think the most important pillar, which is protecting against the threats once your AI applications and agents are live. Now, when before I speak about the solutioning here, I wanted to double click on how the application architecture has evolved over time. Most of the participants on this call, I'm sure, have seen the era of the three-tiered application architecture, where we used to live in times where we had a front end or the UI UX layer, followed by the application layer where your backend logic resided, and then your data layer. It was pretty simplistic, deterministic, rule-based. You could manage the attack surfaces very well. From that came the cloud times, when we moved on to microservices architecture. And now I think what we are living in is the third way of AI application transformation, where there are many more surfaces that come in play. When we talk of an AI application, it just doesn't have a data layer or a application layer or a front end or a UX layer. It also has a model, which is kind of its brain. It has tools and plugins that it interacts with. It has just even if you just speak of the data, we now even have training and inference data, different types of data that come in, and internal and external data sets, that your model uses to contextualize its response. Now, having said that, what that means is, now your attack surfaces have increased, which also means your risks have increased. You need to now take care of your supply chain risk, like, my model, is it safe? The data that I'm using to train my models, has it been poisoned or not? In terms of posture risk, you need to see, are there any misconfigurations or permission issues? Are there any data exposure risk? When it comes to runtime attacks, you need to secure for prompt injection and sensitive data leakage. Now, this is only when I'm talking of AI applications. The moment this moves and proceeds to an agentic architecture, you also have MCP servers coming in, you have memory coming in, you have skills in play. What this means? More attack surfaces, more kind of risk. You now have to take care of governance risk and identity risks as well. Why identity risk? So far, we were performing actions, we had a user identity on our machines. But the moment agents have started acting on our behalf, it is very important to segregate which action is taken by a user and which action is taken by an agent. This is where identity risks come in play, and also traceability, that if I have performed an action and a whole workflow has been followed, you need to see who followed that workflow, who had the permission, how did they perform that action, whether it was a human or agent that was tasked with doing that event. So when it comes to agents, you can't look at security from the traditional lens. You have to look at security from the lens of identifying the giving an identity to your agent that is performing tasks on behalf of you, and not just giving it an identity, but also enforcing identity, giving it least privilege access, and seeing that the agent only has access to the right level of tooling and permissions to perform an action. Think of emailing or inbox kind of an application. Imagine that you had designed it to only read as well as summarize your emails, but somehow in the permissions you forgot removing the send and write access. Now it can even accidentally sometimes even write and send an email on behalf of you. So those are the kind of attacks we want to prevent when we are living in the agentic world. Second, monitoring. This is where a big part of observability comes in, to see which agent has access to which tools, what memory, and how it performs its actions. And lastly, stopping those threats that occur at runtime, whether it is excessive agency like I spoke of, or it is tool misuse. Now, when it comes to securing, right, let's move on to talking about the solutions that can apply at the protection layer. The first one is the agentic runtime security itself. This is something that you can, a runtime security you can consider as more as a guardrail that you can apply at different layers, whether at a developer layer, which is the application, or you can apply this at the network layer. What it helps you to do is protect your application against threats that are happening in real time, whether these are, application threats, whether these are data level threats, or these are model level threats. So a runtime security solution ideally helps you in all of those. And it, like I said, it can be applied at the network layer or the development layer, as well as in different kind of environments, low code or pro code. The second that we spoke of, the agent identity security. The very aspect of agent identity security first starts from creating an inventory of everything that you have, all the agents that you have in your system, whether these agents are custom built agents, enterprise agents, or SaaS agents that you have purchased from SaaS providers, say like a Salesforce or otherwise. Once you have identified what your agents are and assigned them an identity, only then you can talk about ownership and permissions, and that's where you can implement least privilege access principles. So the second aspect of protection comes from identity. And lastly, but most importantly, uh, I think when we speak of securing your AI lifecycle, especially from the build perspective, observability comes in play in a very big way. When you have an AI gateway, it acts as a central control plane for all your AI traffic. Think about it as a place where you manage all your AI traffic. On the left side, you can imagine all your AI applications, agents, whether they are first party, third party, enterprise, browser agents. And on the right side are all your LLM providers, your MCP servers, your toolings. So any traffic, while it goes to the right side, it has to pass through the gateway. Now, what does this do? The moment you start enforcing an AI gateway, it gives you access to enforce runtime security, enforce identity, have governance over who uses what at what time, as well as observability. If you want to identify as a security professional which business unit has access to which model and which MCP server, this is where you can manage and catalog all of that. Second aspect of it, routing, right? When you say that one LLM, for example, goes down and you want to configure a fallback mechanism, that's also something that can be done as a gateway level, and that helps you to keep your systems up all the time, manage, control, as well as provide all the visibility that is required at runtime. That kind of concludes the section where I wanted to talk about the different aspects as well as the solutions that apply to it, and I want to move about creating basically tying it back to the thought map that we started with. And here you can see how at different layers of the mind map that we walked through, the different solutions can apply. While there are point products in the market, I would strongly recommend whenever you are going with anything, especially your AI security, always look at platformization, something that you can give, that can give you an end-to-end security solution. While AI itself has evolved over time, right, and at the pace that none of us expected, it is also important that security matches up. And we at Palo Alto have also innovated and built across that journey starting from July 2024, when we first started with the AI runtime security solution and launching posture management. Today we stand at having a very complete rounded portfolio where we have agentic red teaming, we have AI gateway, we have an identity security solution, we have artifact scanning, and apart from that, we also have security solutions that help you with securing your browser traffic as well as your endpoints. So at this time, I'd like to move to a quick demo and see, walk you through the journey that we just spoke of. Okay, so moving to the demo, let's talk about the go back to the framework that we spoke of. The first aspect of the framework, like I said, was discovery itself. So a discovery module would ideally present to you what all are the AI assets in your enterprise ecosystem and how they are interacting with each other. While it discovers that, it also ideally gives you alerts across all your AI assets. In this case, it has given us an alert around an agent, and let's go ahead and double click on what that alert looks like. As you double click on your agentic alert, you see that the discovery module has also not just found the agents, but it has also categorized your agents in the 4 categories that we spoke of. Whether your agents reside, on your enterprise agents that reside on your own cloud, cloud tenants as well as your data centers, or these are SaaS agents that you have procured from SaaS platforms, or they are say endpoint agents like Claude running on your developer laptops, or browser agents that you're using on your day-to-day basis, say like I mentioned, updating the systems of record. In this case, the alert here is specifically for the enterprise agents. So let's double click and see how that proceeds. As we go on and look at the alert that has been highlighted by the discovery module, we see that there is a claim processing agent, and the alert that is highlighted is that this claim processing agent hasn't gone through artifact scanning so far, and hence it is vulnerable. So let's start the agentic flow and see how the agent artifact scanning happens. Once the agent artifact scanning happens and it goes through your code base as well as your models, it has discovered that in the workflow, especially regarding a search API, there are different vulnerabilities that have been identified that expose your application to prompt injection as well as data exfiltration attacks. At this time, it also gives you an option to start the auto remediation. Let's go ahead and start that. Okay, so now here you see that the moment the auto remediation starts, it goes to GitHub, pulls the request, performs the applies the runtime security hooks, applies the AI gateway, performs the integration, does all of that job for you, and then it implements the code base and pushes the chain. Now, when it has done that, it recommends you, since the code changes have happened, you should also red team your application again. So let's go ahead and start red teaming. Now, before typically red teaming happens, like we spoke of earlier, in the red teaming, in the red teaming section, we have a profiler agent first kicking in. What a profiler agent does, it goes ahead and identifies what is the business context of your agent, what is its architectural details, what are its system capabilities, and creates a profile around it. This is the context that it builds and then passes on to the attacker agent, which now has all the contextual information for it to design those specific attacks that it want to run in the red teaming scan. At this stage, the red teaming scan has completed, and now let's move forward and look at the various insights that have been, that have been produced by this red teaming scan. Okay, so here you are on the red teaming scan page. In this case, it has identified that your claim processing agent is a high risk agent with a score of 76. How it has done this? It has actually in the background run around 4,500 attacks spread across 4 different attack categories of safety, security, brand reputation, and compliance. You may also note here that the 4 different categories all have different attack success rate depending on the prompts that belonged to each of these categories and how they were able to be executed. Now, while it gives you a good overview of how your application's risk profile is at this point, it also gives you recommendations to go ahead and make the necessary changes and apply the security principles. So let's move ahead and look at the first recommendation it has provided at this stage. Sorry, I think I skipped a bit over there. Yeah. Okay, so over here, if you see the very first recommendation that it provided was that the runtime policies are not yet applied to your agent. So we go ahead and apply those runtime policies and this vulnerability gets resolved. Let's move on to the second one. In the second in the second recommendation, the platform has highlighted and specifically the AI gateway has actually identified that your claim processing agent is missing authentication, and it gives a recommendation to identify and apply identity and privilege controls. So we go ahead, apply those controls, and see that most of the vulnerabilities that have been highlighted by the platform are now taken care of, and all the issues and vulnerabilities are resolved. Now, when you look at the screen, you also, this is kind of the interface of the AI gateway where you see what prompts are being sent to what models, and which tool calls are being made and which MCP servers are being invoked to which applications. So an AI gateway, like I mentioned earlier, kind of provides you that central control plane to be able to manage all your enterprise AI traffic, hence giving you access and control at a central layer, whether it is implementing routing, whether it is implementing fallback configurations, or whether it is access control. All of that, or even for that matter, cost management, right? A big question that even the finance teams, for example, the CFO is handling is the increasing costs of AI. And that's where kind of an AI gateway comes in play, where it helps you do cost controlling as well, where you can assign that a specific business unit should only get access to these number of tokens, say, 10 billion tokens a month, or 100 dollar worth of cost of tokens. So all of those settings is something that can be managed at the AI gateway layer. So at this point, all our vulnerabilities are resolved. Our system looks good and healthy. And that concludes my demo. So just to summarize, right, we spoke about first, a differentiation between using the part of AI and building part of AI. We moved on to creating a thought map of how you look at security when you go through your AI dev lifecycle, a framework of discover, assess, and protect, and at the end of it, different solutions that apply, and looking at it at a platformization angle. With that, I will encourage all of you to, if any of this interested you and resonated with any of the problems that you are trying to solve for in your organization, I would definitely recommend you to speak to a security expert, or also go through our demo tour. We are happy to do a very detailed demo for any of you as required. I'll leave this on the screen for a bit so that you guys can take a scan, And with that, I will, open up to questions. Vikas, over to you. Maybe Chintika, you can also come into the video.